Hi everybody, today's a great day because we're going to talk some OChem. Well, this is Maria Thomas and today we're going to discuss activating and deactivating groups on benzene and what sort of directors they become. So, what do we mean when we say activating or deactivating? Well, the way benzene reacts is by using its electrons in this pi bond to react with something else. And so you can say that it reacts using its area of high electron density. So now let's imagine if there's a group that's attached to the benzene that's actually giving electron density to the benzene, that would help it use electron density to react with other things, right? So a group that donates electron density to benzene makes it more reactive or more active, and that's why it's called an activator. Now, let's say there's another kind of group that actually withdraws electron density from the benzene, making the benzene actually more electron poor. What sort of group do you think that is? Well, it's deactivating the benzene, making it less reactive, and therefore it is called a deactivator. So now you must be wondering that, yeah, sure, some of these activators can make the ring more reactive, and deactivators can make the ring less reactive, but is that it? Actually, no. They can actually direct new groups. So let's say this orange guy is the activator or deactivator that's sitting on the benzene ring, and the white guy is a new group that's trying to get in. Well, this activator or deactivator will decide which of these remaining positions the new group gets to sit. Now there's two kinds of directors. Ortho-para directors, which make new groups go to one of these two ortho positions or this para position. And then you've got meta directors, which direct the new group to one of these two positions. And remember, all of these positions are relative to the original group that you're considering. So let's take an example. So let's say you attach a new group to the para position. You get this ion, this uranium ion, that actually has resonance stabilization. And you could move things this way to get this structure, and then move this bond here to get another resonance structure. And if this original director had lone pairs, only if it did, then you could create one more resonance structure by pushing it this way to get one final resonance structure. And you would actually have gotten these same four resonance structures if you tried to add it ortho or para. But actually, if you pay close attention to this structure, you notice that there's a positive charge right next to our director, and if they have lone pairs, then it can bring those down. But the point is, you wouldn't want this positive charge or this lack of electrons to be right next to a director that has hardly any electrons and that actually withdraws electron density. It's okay to have it next to someone who has lone pairs or someone who has some electron donating capacity, such as your strong, moderate, or weak activators, all of whom are donating electron density, or your weak deactivators like fluorine, chlorine, bromine, all of which have lone pairs also. Lone pairs that are right next to the ring. But now, what if you added the new group in the meta position relative to the original orange director? So now you've got another uranium ion that also has some resonance going on. And there's one more arrow pushing to get your final resonance structure. But now if you actually look back at these three structures, you'll notice that not at a single time, never in fact, did this positive charge end up right next to, our original director. So this is actually perfect for strong and moderate deactivators, which pull away electron density from the ring, right? So when they do that, you never ever want your lack of electron density, your positive charge, to end up in that area that's already having electrons pulled away by your director. So strong and moderate deactivators are meta-directors. So let's do a quick recap of what we talked about today. Activators donate electron density into the ring, while deactivators withdraw electron density from the ring. But now this activator or deactivator that's on the ring can actually decide or direct where the new group that you're trying to add is going to come. Now, based on the uranium ion, when you attach the group ortho or para, you end up forming this kind of a structure wherein you've got a positive charge that's right next to your original director. But now, if the director is an electron donating group or if it has lone pairs, then it can actually stabilize that positive charge by donating these electrons down. So the things fitting that category are all of your activators and your weak deactivators. They are your ortho-para directors. But if you attach the new group on the meta position, you'll notice that the positive charge never ends up on this carbon next to the director, no matter what resonance structure you draw. So that would be the perfect position for a group like a strong or a moderate deactivator, which withdraw electron density and have no lone pairs to donate directly to the ring. So these two groups are your meta directors. And that's it for now. I hope this video was helpful for you guys. Thank you for watching.